Good morning, everyone. I My name is Chima, Duru, and I'll be taking you on the topic cost governance and return on investment of AI systems in production. So it's more about looking at how we can actually operate AI responsibly and profitably at scale. Because these days, right now, that AI is the thing. Organizations need to know how to look at the cost, look at the governance and the return on investment, so there can be better administration and better management of their AI systems during production. And this is majorly around my experiences and the research that I've done recently. So just keep glued while we continue on this session. Uh, so we will be looking at why is AI in production different from every other um, every other technology within the production environment. So the first thing is that AI is actually non-deterministic. This system behavior is non-deterministic. So most times we can't determine, most times we can't predict how it's going to operate. And that is one factor that it makes the whole scenario differently from other systems. Then the next one is that it's has a strong dependency on data quality. So if the data is the data quality is low, then it's definitely going to affect other aspects of the AI within the production. And regulatory and ethical exposure with AI, the data within organizations and data within the organizations are being exposed, and then with the um, with the GDPR rules, data actually needs to be at the right place and be processed within the right ethical framework. So with AI, that is something that is different from other systems because AI has a way of working with various data, and once that is set up, then data that might not need to be assessed can be assessed if the right measures are not put in place. The next one is GPU and accelerator intensive workloads. So that is the AI with AI, the GPU and accelerator. It needs a lot of memory, a lot of computing power, and that's the reason why you see in organizations and in the current tech environment, you see companies like NVIDIA, you see companies like Microsoft, you see most of these organizations now investing more in new data centers, investing more in new power supply, so they can actually power the AI drive and the AI moves because it requires a lot of GPU and accelerator to work well. Then the next one is continuous model drift. Most times AI, because AI most times learns. So as it learns, the AI actually learns. The more it learns, the more it continues to move towards the area to which is learning. So that is one area within the AI. So all these aspects needs to be managed within the AI because AI is actually around software, data, and infrastructure. That is the composition of AI, the mixture of software, data, and infrastructure. Yeah. So so if you have any questions as I'm going on, just feel free to ask. Feel free to stop me so we can actually discuss around that. So the next one we are going to be looking at is the cost breakdown of AI. Remember the topic for today is the cost the cost, we're actually looking at the cost governance and the return on investment of AI systems in production. So we are going to be looking at right now, we're looking at the breakdown of the primary cost components. That's so the infrastructure, which is the GPU, storage, and networking. So that is one aspect. In terms of the cloud, if you actually try to set up your cloud environment or try to set up your cloud infrastructure. So for the AI, you definitely need to be looking at the GPU, storage, and networking aspects to understand the load of what you're actually going to be setting up, and the storage, the amount of data, and the speed, how much there's going to be so much load. So you need to understand the speed so that can be accommodated. Then the next one is the primary cost. The next one is model training and fine tuning. That is one aspect that it's a cost that is being within the AI systems, is one of the costs within the AI systems. Then the next one is inference cost, which is per request, because most times the AI systems, uh, when it's set up, when the agents are set up, or when the bots are set up, most times before they can communicate with a particular system, or before they can try to get data from a particular a system, or a particular environment, or a particular software, or a particular location, most times that request that it gives to request for the data, that request, most of these softwares or systems actually charge for that request, um, either per request or per token. And yeah, so the next one is the data pipelines and feature stores. And the next one is monitoring and observability. And the next one is uh, engineering and maintenance. So these are like the primary costs, which is the major cost that is usually very visible when you actually set up your AI systems within the production environment. And yeah, there are some hidden costs apart from the primary cost, and that is around retraining of cycles. Like I mentioned earlier, there's that aspect of model drifting and experimentation sprawl. And then the next one is unused GPU reservations, which sometimes that can actually lead to some kind of increased cost, and token overconsumption. That is also something that is a very that needs to be looked at. The token overconsumption. So we are going to be looking at nextly the visual AI production cost architecture. We want to look at how the cost flows. So usually the users or application, depending on how the AI system is, the users or applications actually um, either makes a request or performs an action, and that routes through the API gateway or the load balancer, which trying to measure the traffic and trying to measure the load, and then over to the LLM or the ML serving. That's the inference layer, which is the per request or per token, and then goes over to the vector DB or the feature store. And we then after that, which is the database, because this inference layer tries to get some makes a request to get some data from the database, and once this database actually makes that request, then over to this value goes over to the data pipeline and storage. Then so within that framework, once that is actually done, it now goes to the point of the model training infrastructure, where that request and that data is actually being trained, added to the system, so the system can actually learn from that process. And yeah, so in this area, we look at the cost concentration by layer. The inference layer actually has the highest cost. If we look at the inference layer, because that is the point where is at the per request or per token to the database, and retrieval, that's the embedding and vector storage, the embedding and vector storage cost, which is from the database. And the data, we actually need to store the data and processing cost. And the training, that's the periodic, because most times it's not all the time. The periodic training, it's actually expensive, but since it's not every time for the training of the model. And the areas like the monitoring, security, and CIDIs, which is the areas that we actually look at within our scope, which is the area. So that is a cost that is usually being assessed. So the next one is we are going to be looking at cost optimization strategies. We want to try to understand how do we optimize the costs? How do we try to ensure that what we are using is actually what we are actually consuming is actually what we are using, because sometimes we might be consuming more than what we are using, or sometimes we might be consuming less than what we are using. Sometimes we set up a system, and we notice that we actually don't have a control of what we are consuming. And most times our budget, we're actually overshooting our budget, or we are going beyond, or we set up a system and we are not using the full value of what we set up. So how can we go through, have a strategy, set up a strategy? I'm just trying to give an overview of how we can actually set up a strategy on trying to optimize costs. So one way is by model right sizing. Try to right size the model. Try to give the model a good framework. That's the model that is being used, the AI model that is being used. Try to right size it so it's fit for use. And then the next one is quantitizing and distillation. That is one aspect that we actually use, one of the strategies that we use for cost optimization. And spot instances for training, as much as possible, try to understand try to do some spot instances for training, and cost dashboards per model. So every model, if you as within the production, if you can actually have those dashboards where we can be seeing our consumption per model, that will actually help us to that will actually help teams and organizations to understand how they can actually pivot their AI systems or structure their AI systems, and know which areas are costing more and which areas are costing less. Then response caching. So yeah, so as much as possible, trying to clear up the cache, trying to clear up the response and monitor the caching. So there's not so much within that area, because if not, the load is actually going to be so much, and that will determine that we are going to be getting some cost from the networking and from the storage areas. Then the GPU auto scaling as much as possible. Yeah, set up the auto scaling so we don't set it up in a way that we actually consuming more while the system is actually currently running at a place where it's not consuming up to what we set. So it will not be of use. It will be more like a waste. Then setting up token limits and budget caps, that will help. So at least when the per request or per token is actually, when those requests are made and it's reached that limit, then it at least you know that, oh, you've actually reached your budget limit, and then you can then try to set up or tell yourself, do I need to continue or do I need to pause, or am I done for this month? And maybe we can roll over that to the next month. Or you can actually know, okay, maybe set up a limit when you're at 50% or when you're at 70%. So you can be able to track the AI system usage within your production. Okay, so then we'll be looking at the FinOps, the financial aspect of the cost production that we're looking at for the AI systems. So cost allocation, as much as possible, try to allocate costs. This is just the budgeting and the financial aspects. Need to try to allocate costs per team or per model. So at least we know that that is the budget that we have. Then setting up budget alerts and anomaly detections, that will help. So we can be able to have a track of what is being consumed and then how we can actually structure our systems. Then the next one is cost and revenue dashboards, which is what I mentioned earlier. So for the FinOps, and especially for the teams that actually work with the finance teams, the advisors, so we need to always set up that cost and revenue dashboard. So our cost and actually our revenue, so we can be able to determine, oh, are we actually spending more than we are earning? That would actually mean track cost per 1,000 predictions. Yeah, so we can actually do that. Or show back or charge set up show back or charge back models. Yeah, so that can be done. So we are going to now look at AI governance frameworks. AI governance frameworks, because like we started earlier, the topic is we are looking at costs, we are looking at governance, we are looking at the return on investment for AI in production. And that is, at the moment, we are looking at AI governance framework. So we want to look at the framework. So just like we mentioned earlier, the governance framework is how we govern, how we manage, how we try to ensure that the AI systems are within our control and within our sphere of influence. So there are various areas where we actually look at within AI that we can actually apply governance to, which is data, setting up policies, for data quality, data lineage, data access, and privacy controls. Those are very key. We need to set up those within the sphere of data governance and privacy controls. Privacy control is something that most organizations should look at doing. And the next one is model governance, trying to set up those within the AI models, registries, versioning, approvals, performance, and drift monitoring. So those actually need to be set up. So, and just like we mentioned earlier, within the cost and this thing, we actually need to have dashboards to monitor this, to monitor the abnormalities, and then to try to find a way to continually have a system of continuous improvement of the model. And the next one is to actually look at, because right now with AI, security is very key, because most hackers are actually trying to use AI as a backdoor into most organizations. So we need to ensure that our AI governance framework is actually managed, the security controls is actually set up for threat modeling and encryption and rate limiting. So we need to try to encrypt some of the data within our organization, and input and output filtering. Yeah, please. So if I'm very fast, just let me know so I can stop at some point. So I could if you have any questions, like I said, you can let me know. So I'll stop and we can take those questions. Then the next one is compliance alignment, which is because depending on the interest, especially for the banking industry and some government organizations and NGOs and some kind of critical organizations, compliance is key. And within the AI framework, we should the governance framework, we should ensure that we set up, align our AI systems to be within the compliance framework, to align with any compliance framework within our organizations, whether it's the ISO or whether it's the GDPR or whether it's every other and compliance framework that needs to be followed. So we need to align regulations to standard and maintain auditability. So in case we need that, we need to send in our audit. So every single step must be followed, depending on the regulatory framework that we are actually following. Then responsible AI principles will need to be set. That's within the areas of fairness, transparency, safety, and accountability in AI use. That's all these should will need to be set. So this is not just bringing organizations to set up just documents and putting that one side and saying, oh, this is our governance framework. No, it's beyond that. The systems will need to be set. The areas of data, in the areas of the AI models, in the area of the security controls, in the area of the compliance alignment, and in the areas of responsible, the principles governing the organization's AI. So the goal is actually to reduce operational, legal, and reputational risk. So that is the goal of these two, because we need to ensure that we put this in place so we can be able to have things under our control. And if organizations don't put this in place, then they're actually putting their organizations in a risk, either within the operational or legal or reputational area. Yeah. So AI data governance, we are going to look at data governance in AI. So usually it's the AI, what's about AI is as much information as we have, as much data that we have within the organization is actually that we are increasing our liability. So if we can more importantly track the data lineage, track every data versioning, track the data lineage, track data set versioning, track data retention policies, even the PI detection and masking. That's the private information detection and masking. Then also set up role-based access controls within the data, so that can actually be tracked. So if any of the systems actually accessing the data or using the data, then it can actually be tracked who accesses the data, who uses the data, and what the data is actually being used for. Then privacy compliance, either within the European Union regulations. So this is the data governance. So then the model governance, we'll be looking at centralized model registry. We need to ensure that we set up a centralized model registry to have that registry for all the AI models that we have within the organization, and then to also ensure that the approval workflows are being documented. The approval workflows are being documented, so we can actually understand what is our approval workflows, and then how does it work before any data, before the model actually accesses any of the data, or before the data actually goes through a particular setup. Then the next one is performance monitoring. We need to monitor the performance of the model. So that should actually be something that we need to set up within our governance framework, monitoring of the performance of the AI systems. Then versioning control then audit logs, because all these things will need to be in place. So um, we just need to treat the models as deployable and versioned artifacts. So that is yeah. So that is within the production. So audit logs whenever there are any issues. So audit logs whenever there are any issues, we can be able to go through it and be able to monitor, understand the actions that we have been taking place and how we can look at that, because this will ensure governance and drift detection. We need to be able to understand where, because AI systems, they continue to learn, and the more they learn, they could drift outside of the initial purpose that they were set up for. So we need to ensure that those are being, all those metrics and all those systems are set up so we can be able to detect um, drifting. We can be able to detect the drifting within the model. Okay, so the security and compliance risk is something that we need to take very seriously for the AI systems. So risks like, which is are like core AI specific risks, are prompt injections. Prompt injections are very, just like I mentioned, we can actually have some bad actors that can actually inject some prompts into our AI systems, and that could collect some data that are very useful for and some data that are very private and that would not need to be seen outside. So prompt injection, data exfiltration, model poisoning. So these are the areas that are very important to be looked at, and because that is the areas where bad actors are looking at API abuse and hallucination risk. If we had time, we would have had be able to discuss that. Maybe in the next sections, we might be able to like go over this and look at this in more detail. So the mitigations of prompt injection is to ensure that we ensure that data input is actually validated. So if any data, if any input is validated, if any prompt is actually being input, it needs to be validated. There should be a system validating any kind of prompt. And um, the mitigation for data expiration is to ensure that output is actually being filtered, any output after the AI actually after the system, after the AI agent goes through, gets the data, tries to make an inference from the data. Uh, the mitigations we should ensure that the outputs are being filtered within a particular area. So that would mitigate the area of data expiration. Then model poisoning. So model poisoning, sometimes that can actually be done, and we will not be able to monitor the rate. So the mitigations are, we should ensure that we set up, put limits for the rates. And then API abuse, we should try to encrypt our APIs. That's the mitigation. Once we encrypt our APIs, then no kind of systems that are not allowed or doesn't have a relationship with our systems will not be able to uh, have access to the APIs. And hallucination risk, the mitigation is secure prompt logging. So that could actually be something that we can set up to mitigate hallucination risk. Okay, so the next one is, how do we define return on investment for AI? Because that is very key. If we are setting up AI systems, we need to also know that what we are setting up, is it going to give us a return on the investments that we are making? Because looking at it on the face value, sometimes AI, we look at it and it's more like, oh, we are spending so much. Most times it's almost like we are spending so much. So we need to have a different lens of looking at how much are we spending and what is the business value of the AI systems that we are using. So to understand if the amount of investment that you're putting into the AI systems are actually going to be the same value that you're getting. So most times, yeah, as businesses and in production, the key thing is to understand if you're actually having a return on investment for any kind of investments that is being made. So the return on investment calculations is the business value minus the total cost of ownership. That's divided by the total cost of ownership. So that would give us the return on investment. That is the formula. So the business value sources, which we can actually measure the business value from various sources, which is from revenue uplifts. That's growth from new and improved offerings, or operational cost reduction. If the system is actually going to reduce operational costs, that's the operational cost maybe from the amount of machines that are being, the amount of other machines, the cost of other machines. If having an AI system would eliminate the use of some other devices or machines within the organization, then we need to calculate how much does those systems or devices cost, or if it's going to eliminate the human task, then how much time and how much does it take for a human being to perform that task within that jurisdiction. So how much are you going to employ someone to do that task that AI is actually doing? So it's something that can actually check the operational cost reduction. If it's actually going to increase efficiency, make the work faster, then if we make the work faster, we need to know, okay, if a human does that within 10 hours and the AI does that within 1 hour, then we need to know that, yeah, we're actually saving time and the business can actually grow faster. We need to calculate that. And then automation savings, yeah. The next one is productivity gains. Faster delivery actually should be measured if within production there's actually a faster delivery and throughput, then it should be measured. It should be measured within production, especially within the software software production environments, where we need to be able to understand if the AI systems are helping the software engineers deliver faster and them have that increased throughput and risk reduction. If it's going to lower losses, if it's going to actually lower losses and exposure, then that is something that will be looked at. So if the return on investment is unclear, then most times the AI project it's not best to go into. So we need to most organizations will try as much as possible to define what is my return on investment on the AI system that I'm actually setting up within my organization. That understanding should be put into place. Okay, so the return on investment measurement framework. How do we measure return on investment? As much as possible, the first thing we should do is to define baseline metrics. We should define baseline metrics. We should capture the current performance. We should capture the current costs. We should capture the outcomes actually before introducing AI. All those metrics will need to be captured So because if we don't capture it, if we don't know where we are at the moment before AI is actually being the AI systems are being set up, they will not know the value that AI is actually bringing in, because we need to be able to calculate that. Then the next one is um, we need to do a controlled rollout. That's perform an A/B test, A/B test, and compare AI versus a controlled or isolated environment. So we need to get a controlled or isolated environment and try to isolate different scenarios and try to understand, okay, in this scenario, this is what it gives. In this scenario, this is what it gives. And with that, the next one will be able to track the cost per inference, track accuracy, track latency, track business impact. And once that is done, then we can then measure the payback period. How long does it take until we can now get the total, until we can now start seeing that return on investment, looking at the time until cumulative value exceeds total cost of ownership. So we are actually looking at the time until we get to that point of we've actually reached that line of exceeding the total cost of ownership. And at that point, then we can then say, okay, we are actually going getting paid back. We are getting some return on investment for what we paid. So all those metrics, one thing about this is that the metrics need to be defined early, and with that we can then be measuring it, and then we can now measure the payback period and continuously it reevaluates and continually check, adjust models, budgets, and guide rails as the data changes. That is very key. So if that is set up, then we'll be able to understand, okay, where we are at and what we are looking at, and maybe strategize for better output or strategize for a better outcome. That is very key. Then the next one, we are going to be looking at a case study. Okay, we are going to look at a case study for a customer support bot that was set up. That was set up. Let's just try to look at the case study. So, say peradventure you want to set up a customer support bot within your organization, and then the system overview is that normally, usually, there's that 5,000 queries per day within your customer support environment, and then the RAG architecture, and you want to set up that to have that 24/7, 247 availability. So normally the monthly cost would be that we are looking at the cost because we want to look at what does it normally take to set up this kind of system, and then we want to look at the cost just for something like a customer support when we set up a customer support bot. So the monthly cost breakdown could be the inference cost could cost around $18,000. Then retrieval cost about 5,000, and the ops and monitoring could cost around 7,000. That's the total AI cost. Then the return on investment. So before, like we stated earlier, we need to set up the matrix before AI was actually the AI was set up. So before AI, actually had 20 agents. This let's say this company A actually had 20 agents working, 20 customer agents, human beings working for this organization. And like we mentioned earlier, they actually had 50,000 queries per day, and it was a 247 availability. So that cost for 20 agents is going to, depending on the area, going to cost around $180,000 per month. Yeah, which is a very high cost. And then after the AI was set up, the system was actually 35% automation. And by setting up the system with 35% automation, the 120 agents that was being used because of most of the repetitive actions and most of the actions that have been set up. So right now, the agents can now do more with the systems, and there will be less need of human beings to do the tasks. So the agents are actually going to be reduced to 85 agents, and the cost per month has now reduced by 340,000 per month, which is per agent. So we see that that has actually been reduced 340,000 per agent. And in order to automate this system, it's just cost only $30,000. So if we now want to do the calculation at this moment after AI, the AI, this organization is actually now going to be spending $370,000 per month, which is quite a good metrics. But if you look at the savings, that is about 110,000 net savings in a month, which then we look at the return on investments, which is about 267,000. Yeah, so this is how the return on investment is actually calculated. Return on investment is about 267,000, 267% return on investment, which is a lot. You can imagine saving that amount of money. This can be reinvested into the organization. This can be used especially for startups at a scale. So most times the payback period would likely be less than a month. Yeah. So this is just a good overview of how the return on investment and the cost of a customer support bot, if organizations actually set that up, and how to calculate the return of investments. Then the next case study is the engineering AI assistant. Yeah, so use organizations could actually set up. Company A actually sets up an engineering AI assistant, and this organization actually has 500 engineers, and these 500 engineers all makes 25 queries per day each. So you can imagine 25 queries per day each multiplied by 50 by 500 engineers. We know how many queries that this organization actually makes, and the RAG plus the LLM architecture. That's what was actually going to be the system that is going to be set. So the monthly cost actually is roughly around. So we're just trying to look at the cost, the monthly cost of AI for this organization, roughly around £14,000 per month, $14,000 per month. Yeah, so the productivity return on investment, because we are now looking at this not just from the raw cost savings, but we are actually looking at it from the productivity return on investment. That these engineers right now, how much more can they do? How faster can they deliver? How much more is the organization going to be more effective and efficient right now? So these engineers now are now saving 20 minutes per day per engineer, which is roughly about 3,652 hours per month, which is, yeah, so the productivity value, if we do that calculation by the amount, the productivity value, which is which was how much that we calculated, the amount that we calculated for this one. If we look at the total cost of AI, if we want to do that amount by this one, then the productivity value is 182,600 per month. That is the value. So the return on investment, you can't compare that, because right now you can actually deliver more. And yeah, so most times the productivity return on investment might not necessarily mean that headcount is actually going to reduce, but it actually means that organizations can now deliver faster, and innovations can actually happen faster, and you can actually shape faster. That is the key thing about looking at it from the productivity angle, the return on of investment. So um, most times within the return of investment, sometimes things could break. If things are not properly set up, then the return on investment might not be like all we just looked at right now. Because if there's things like token explosion, if this token explosion, if that is not being monitored, if there are not limits set up for the token, or if there's a poor adoption, a poor system on how to adopt, or maybe there's a model drift, the model starts drifting, or maybe there's weak governance or security incidents or regulatory penalties, then the return on investment is actually not going to the AI in return. So if this, just like you mentioned earlier around the governance, this actually needs to be set up properly. If not, that would actually affect the return on investment. So, just like we mentioned now, there should be that balance between cost, governance, and return on investment. Over optimization would actually slow innovation. So, if there's so much, the cost is actually being optimized so much, then is actually going to affect innovation. And if there's weak governance, it's definitely going to affect risk, which is definitely going to increase the cost. And if there's no measurable return on investment, then AI is not going to be sustainable, because we'll not be able to measure what the organization is actually using, and the amount of value that that is actually bringing to the organization. So um, as much as possible, if this whole areas of cost, governance, and return on investment can be automated, then there's definitely going to be that balance. So right now, we are actually seeing that the DevOps environment is moving from DevOps to MLOps and to AI platform engineering. That is where we actually seeing that move. So how do we manage the platform to give us the best value that we want? So the key takeaways of this discussion, of this section, is that AI actually has ongoing operational costs, and governance must be embedded in pipelines. But governance must be embedded in pipelines, and the return on investment must be measurable and continuous, and financial and technical observability is always very critical. Monitoring, observing, and seeing where the current state of things are, of the systems are, is very important. And AI in production is it's more equals to a product and not experiment. So I'll be leaving with this closing remark that AI in production is not a model problem. It is an operational excellence problem. Yeah, so that's, I'll just be leaving my closing statement. And so that will be the end of this session. If you have any questions, please just drop that on the chat. I'll be going through the chat, and maybe we could address that in the next section, or if we have time, we could address that now. Just drop that on the chat, and I'll just go through the chat and have a look at that. If there's time, just looking at the time, if there's time, we could address that, or I could actually reach out to you and let you know about the areas that you want to look at. Okay, cheers.